Hi everyone. In this lecture, I want to show you the design process of active bandpass filter. Let's assume that we have an ideal low-pass filter and an ideal high-pass filter. Let me draw the frequency response plot of an ideal low-pass and high-pass filter. I'm assuming that the gain of both of them are equal to 1. So now I want to know how I can make a bandpass filter if I have a low-pass filter and a high-pass filter. So by looking at the frequency response plot, I can see that the low-pass filter is passing lower frequency up to omega C2, and the high-pass filter is passing high frequencies from omega C1 and frequencies greater than omega C1. Now, if I'm looking for a middle range frequency to be passed by the filter and to be killed by the filter anywhere else, then I can think of cascading these two filters. Obviously, if I cascade a low-pass filter and a high-pass filter, what will happen is that the low-pass filter will kill the higher frequencies, and then the rest of the frequency spectrum will go through the high-pass filter. Now, the high-pass filter will see only this spectrum of frequency, and obviously it will kill the lower frequencies, and the only frequency range that can pass through both of them is going to be omega C1 till omega C2. So the only range of frequency that can survive these two filters are going to be frequencies between omega C1 and omega C2. Now, when I was trying to see what happens if I cascade a low-pass and high-pass filter, I made a default assumption that omega C2, or the cutoff frequency of my low-pass filter, is greater than the cutoff frequency of my high-pass filter. If it's not the case, then what will happen is that I'm going to have something like this, and then the first filter will kill all the frequencies greater than omega C2, which is here, and only this part of frequency will survive. And then this range of frequency cannot go through high-pass filter because it's lower than its cutoff frequency. So it means that no signal can survive both of them when they are cascaded. So I can use a low-pass and high-pass filter. I can cascade them. So if the cutoff frequency of the low-pass filter is greater than the cutoff frequency of the high-pass filter, then I can assume that by cascading them, I'm looking at a bandpass filter. Now the question is that what are going to be the cutoff frequency of the bandpass filter? I'm going to show you that if you want to have cutoff frequencies for your bandpass filter exactly equal to the cutoff frequency of the low-pass filter and the high-pass filter that are cascaded, then you have to make sure that your omega C2 is much greater than omega C1. So if they are widely separated, then you can assume that omega C1 and omega C2 are your bandpass filter cutoff frequencies. But if they are not widely separated, so if they are close, by cascading them, you're going to still have a bandpass filter, but the cutoff frequencies are not going to be the same.